halfway there to finishing up solving with systems. We've learned graphing. Today we're going to talk about in section 2.3, we're going to talk about elimination. Okay. And then 2.4 will be substitution. And those are all the methods we know about solving systems. So 2.3, all about elimination. Now I have provided you with notes on this about elimination. Okay. And I've shown you what the goal of elimination is. And then the process to getting to the answer. And it's only 4 steps. Okay. And I have provided you an example right out here to the side of how those 4 steps are going to work. Okay. So let's talk about elimination. So right here, this is what one of your problems is going to look like. The first thing that you need to establish is the goal met? Okay. Because if the goal is met, you're going to skip right to step 2. If the goal is not met, then we will start at step 1. Okay. So the question is the goal met? Well, here's how you're going to know if the goal is met. It takes 2 things. 1, you need to see if there is a variable, just one variable, but it's cool if there's more than one, but look for a variable that has opposite signs, meaning one is positive and one is negative. So if you look over here, both the x and the y meet that charge right there, because positive, negative, negative, positive. Cool. Both variables have that. But there's a second stipulation that must be met. Okay? Not only do you have to have opposite signs, but you also must have the same number in front. See, 3 and 3. That's the same number. And one's positive, one's negative. So this means, right here, this circle, I'm showing you that the goal is met. So if you have this, we're going to skip right to step 2 and work the rest of the problem. If you do not have that, then you will be doing step 1. Like when you look at this example right here, see how we don't even have one opposite, one negative. So the goal is not met here. So that means we're going to be doing a step 1. Okay? So let's talk about this problem and look at what's going on. Is the goal met? Do I have one positive, one negative, and both the same number? Absolutely. Right here. I have the one positive, one negative, and both have 5. So the goal is met. We can go through it. Let's take a look at another one. Is the goal met here? And again, yes, it is. Look right here. I have one positive, one negative, and they're both the same number. In fact, I have another goal met right here. One positive, one negative, and both the same number. So even better for us. We'll talk about this soon enough. But again, the goal is met here. And it's cool that both of them meet the goal, but I only need one. All right. So over here, when we look at this, is the goal met? And the answer is no. We're almost met right here. I mean, I got a negative, I got a positive, but they're not the same number. This is the number 1, this is the number 2. Okay, so the goal is not met for this one. What about here? Is the goal met? And the answer again is no. The goal is not met. All right, I don't even have one positive, one negative on this one. And I believe I got one more after that. Yeah, so here's the last one. So is the goal met on this one? Well, this is a little different, and I'm going to talk about this one soon enough. Okay? So let's go back and let's talk about the ones where the goal was met. So let's start with this guy. Since the goal is met, we're going to go and we're going to skip step 1. We're going to start at step 2. Step 2 says add down each column. Okay? We start here if the goal is met. So we're just going to add down. And what's cool about this, the reason why they call it elimination, because if that goal is met, when you add down of the column where the goal is met, they're going to eliminate each other. Because 3 plus a negative 3 is 0. X eliminates. That's why we like it when the goal meets, because it just eliminates that variable. And then we'll just add down the rest of the columns. Because the reason why we want a variable to go away is because we can't solve when we have two different variables. But if we eliminate one of them, as in this case, the x's are going to go away. And when I add down, I'll get 5y equal to 1 plus 9 is 10. Now I just have one variable, and I can solve that. Okay? So step 2 says to add down each column. So we add down, we add down, and we add down. Now, step 3 says, all you're going to do is solve for the remaining variable. This should always be division. So step 3 is always a division step, because how do I get rid of 5 times y? We divide. So divide by 5, divide by 5, and we now know that y is equal to 2. So you already know part of the end answer. We know that the y value is 2. Okay? And your answer should look like a point, just like what happened in 2-2. All the answers are a point. So these answers look like a point. Okay? So the y value is 2. How do you find the x value? Well, that's what step 4 is for. So you're going to take that answer that we found from step 3, and we're going to plug it into one of the original equations and solve. Okay? Again, remember I put the little reminder right here. Answer is a point, as I was just saying. So we're going to take this answer of 2, and we're going to plug it back into one of these two. It doesn't matter which one you plug into. Pick one. You're going to get the same answer either way, and I'll show you that here in just a second. So let's say we plugged into the top one. So wherever there's a y, I'm going to put the value 2. So we got 5x plus 3 times, there's a y, which is 2, equal to, I think it's 1. Yeah. And we're going to solve. Okay? So 3 times 2 is 6. So I got 5x plus 6 equal to 1. Subtract 6. 5x equals -5. Divide by 5. And now you know what x equals. X is equal to a -1. So we can now come back up here and fill in. We know that this is -1. And we knew that the y value was 2. Okay? So there's our answer. -1, 2. And you're done. If I plugged into this one, I would have gotten the same answer. Let me show you. So plugging into that, we would have -5x plus 2 times 2, because that was the y value, equal to 9. 2 times 2 is 4. So -5x plus 4 equals 9. Minus 4 minus 4, -5x equals 5. Divide by -5, divide by -5, and the answer is -1. So answer written as a point, -1, 2. All right? So go ahead and try this one. You already know the goal is met. Go from steps 2 through 4. Go. What? You're having a problem with this one? You're saying that you can't do step 3 and step 4? And I agree with you. Because if we add down, because both variables meet the goal, what's going to happen with these? That's right, they're going to cancel out. So on this side, everything cancels. The x gone, the y's gone. So we have 0 equal to, well, if we add down on the second side, you get 8. So this is what happens when we use elimination and we have our special solutions that we talk about. This is either infinite or no solution. Okay? This is either the infinite case or the no solution case. Well, which one do we have? We have the no solution case. How do I know that? Because this doesn't make sense. 0 equal to 8. So if I have no money and you have $8, we're the same? No, that doesn't make any sense. You get to go to Taco Bell, have 8 tacos, and I'm going to be standing there at the window watching you eat those 8 delicious tacos from Taco Bell. Okay, so this doesn't make any sense. So whenever you have a number equal to a number and they are different, that is a no solution. Circle with a line through it. Or in case of your answers in IMATHAS, DNE, comma, DNE. Okay, let's turn these purple. There we go. All right. So in IMATHAS, like I said, this would be a DNE, comma, DNE. Does not exist. Well, down here below my little screen, I have another one just like this. So again, you can see the goal is met. And again, when we add down, everybody's going to cancel out over here. The x's are gone, the y's are gone. You're left with 0. What happens over here on the answer side? Oh, look, the goal is met here as well. So everybody over here is going to cancel out. So I have 0 equal to 0. So what does it mean if you have a number equal to a number and they are the same? You betcha. This is the infinite case. Infinite solutions. Or in IMATHAS, O, O, comma, O, O. Okay? So if your goal is met, they kind of make things easy for you. You're either going to end up solving and getting a point, or everything's going to cancel out and you got special solutions. Okay? So let's look at this case right here when the goal is not met. So we already know that it's not met, and we already know it's not met on this one. Okay? So let's talk about step 1. Okay? Since the goal is not met in step 1, I need you to be active in this. Solving systems, when it comes to substitution and elimination, you have to be active. You as the student have to make choices. I can't tell you what to do. I can only give you the process. That's why I call this a process and not steps by steps, because when the goal is not met, you have to make choices. I can't tell you what to do because it's all going to be about what you see and how you want to approach it, because there are infinite amount of ways to solve this using elimination and infinite amount of ways to solve it using substitution. Okay? So when you look at this, think about the goal. You want 1 positive, 1 negative. I already have that met with X. I have the positive, I have the negative. The only thing that's not met is they're not the same number. So I'm going to choose to work with X. But I would get the same answer in the end if I choose to work with Y. It doesn't matter which variable you pick. Okay? But you got to pick one of them. So either pick X or pick Y. Most of the time what happens is most of you in class, you like to pick on the X. You like to get rid of the X. Okay? You like to get rid of your X's. I don't blame you. Okay? But know that you can also get rid of your Y's too. All right? So step 1 says when the goal is not met, we pick a variable. And what you're going to do is you're either going to multiply one of the equations or both of the equations by a number, because you're going to make it so that they both end up having the same value, 1 positive, 1 negative. So up here in my example, I chose to get rid of the Y. Okay? It didn't matter which one, but I chose the Y. Okay? So all I did was multiply the bottom equation by a negative 2, because that will give me a positive 2y on top and a negative 2y on the bottom, because a positive 2y and a negative 2y cancel each other out. So if I go back over here and look at this, I want to get rid of these two. Well, I already have the negative on top, so let's keep that. I already have the negative on top, so I'm going to call it negative 2x. But down below, I need to turn this into a number that can take away this negative 2. Well, what can I multiply this by? I can multiply this entire bottom equation by 2. Because if I take 2 times x, I get a 2x. See how I turned it into the same number, and this guy's the negative, this guy's the positive. Goal met. Okay, I want to make this happen. Now again, as I said, there's lots of things that you can do. You can't turn it you can, but I wouldn't. Do not make your numbers smaller than the largest one. So between these two, again, remember that there's a 1 here. I do not want to go below 2. Okay? I do not want to go below 2. So I either want to make it 2 and above. All right? So I could have made these both 2, which I did. I could have turned them both into 4s. So I would have multiplied this by 2 and this one by 4. I could have turned them into 6s. Again, it's going to be about what you want to turn them into. But either way, you got to make sure the goal gets met. One of these has to be positive. One of them has to be negative. And they both got to be the same number. Do not turn it into anything smaller than the largest. Okay? If I had chosen the y's, just kind of like spitballing here. If I had chosen the y's, I would have made a 3y and a negative 3y. I would have kept the top positive because it's already ready to go. I already had the positive 3y there. And I would have made the bottom, I would have multiplied this guy by a negative 3. Okay? So if I wanted to get rid of the y's, I would have done 3y, negative 3y. But we're going to get rid of the x's. So let's get rid of the x's. Here we go. So we're going to multiply this entire bottom equation by 2. So 2 times x is 2x. We knew that. 2 times y is 2y. And 2 times 6 is 12. Everyone gets multiplied. Now the top, notice it already matches. So don't change anything. The top equation is going to stay the same. And that right there is a step 1. Notice I made the goal be met. Okay? And now you just pick up with step 2. You already know how to do this. Pause the video, complete the rest of this. Go. Okay. So when you add down, x's go away. 3 plus 2 gives you 5y. 13 plus 12, 25. Divide by 5 for step 3. Oops, let's change that up. Let's change my color because I like to be consistent from problem to problem. So divide by 5, divide by 5, y is equal to 5. And now you know part of your answer. We know that it is blank, comma, 5. Now, what am I going to do? I'm going to take this 5 and I'm going to go back into one of my originals. Now, here's my little platform I'm going to stand on and preach to you for a second. You can take the 5 and plug it back into one of these two guys that you messed with. My advice is don't do that. Because some of you, math magic is really strong with you. Math magic is when, you do some things, but your math isn't correct, but yet you end up with the right answer in the end. That's math magic. So some of you, your math magic is strong. And for some reason, you could end up with the right answer here, But then if you take this answer and plug it back into one of these where your math was not correct, but somehow in the end you managed the right answer, but somehow you plug back into this, most likely math magic does not strike twice in one problem. Okay? So if you take the 5 and plug it back into something that's written wrong here, you're probably going to end up doing your math right and getting the wrong number in the end. This is why I always plug back into one of the originals, because I know the original equations given to me are written correctly. So I can either plug into the top or plug into the bottom. It doesn't matter. You already know that. So I'm just going to plug into the bottom. So I've got x plus 5 equal to 6. Subtract 5, x equals 1. And there's the answer. 1, 5. Okay? All right. Go ahead. Try this problem on your own. And go. All right. So in this one, either variable is easy to get rid of. Okay? Most of you probably chose x, so let's fix the x. Okay? Usually on this problem in class, I make you do the y, but it's fine. So I'm not going to go any lower than 3. So what number can I turn these both into? Well, I can make them 6. I could have chosen 12. I could have chosen 15, or no, not 15. I could have chosen 18. That would work for these. Okay, lots of different numbers. Now, notice both of these are positive. So that means down here, I got to make one of them negative. Who should you make negative? It doesn't matter. Make the top negative, make the bottom negative. It doesn't matter. Usually, I just make the bottom negative. So this is what I want to happen, because a positive 6 and a negative 6 give me 0. Now I can figure out what to multiply my equations by. And I actually have to multiply both of them this time, where over here, I only had to multiply 1. So what times 2 gives me 6? And that will be a 3. So the entire top equation is going to get multiplied by 3. Down here, what times 3 will give me negative 6? And that would be a negative 2. So the bottom equation is going to get multiplied by a negative 2. So let's do some stuff. So 3 times 2, that's 6x. 3 times 5 gives us 15y. And 3 times 1 is 3. So there's our new top equation. Our bottom equation, negative 2 times 3x is negative 6x. We knew that. Negative 2 times 4y is negative 8y. And negative 2 times 12 gives us negative 24. And now we're ready for step 2, because now the goal is met. Okay, let's grab this, move this over a little bit. There we go. So step 2, we're going to add down. What's going to happen with the x's? They're going to cancel. So 15 minus 8 gives us 7y. And 3 plus a negative 24 gives us negative 21. So there's step 2. Step 3 says divide. So we divide by 7. Y equals negative 3. And now you know half of your answer. So something, comma, negative 3. So now I just pick one of these to go into. I'm going to plug into the top one. Again, you can plug into the bottom one. It doesn't matter. So 2x plus 5 times negative 3, because that's what y is, equal to 1. So 2x, 5 times negative 3 is negative 15, equal to 1. Plus 15, plus 15. 2x equals 16, divide by 2, divide by 2. We now know that x is 8. And there's your answer. Cool thing about this, all these answers you can check. Remember, we did this in 2-1. So if you wanted to make sure this was your answer, you can take these points and plug them back in and see if they work for both. If the point doesn't work for one of these, that means you did your math wrong. Okay? Fix it. But you can always check your answer. Just take what you know and plug it back into both equations. Make sure this one equals 13, this one equals 6 when I plug in 1, 5 in. Okay? All right, now let's talk about this last problem right here. They are throwing this in section 2-3. I would not do elimination on this problem. Why? Because this is set up for section 2-4, which is substitution. Okay? And in the notes, I've given you the substitution notes. They're on the second page. Because the goal of substitution is to have a variable that's solved. See how right here, y equals 3x plus 2? Y is solved. We know what y equals. Or right here, x equals y minus 7. We know what x is. X is y minus 7. Okay, if you look at this, we know what y is. Y is x minus 5. I would not do elimination on this. That's more work. I would do substitution. So here's what I want to kind of tell you about this problem. I'm going to work this elimination style because it's in this section and I need you to know how to do it. Okay? But I would not do elimination on this had we talked about substitution already. I would do substitution. So here's some things I want to tell you. I've taught you graphing. I have now taught you elimination. The only one you don't know is substitution. Just because this section is about elimination doesn't mean you have to do elimination for everything. I know the directions are going to say use elimination. Same thing when we get to 2-4. In 2-4, the directions will say use substitution. But if the problem is set up for elimination, why do substitution? This is why we know multiple methods. So the fact of the matter is you do you, boo. If you like to do elimination, you can do elimination on every single problem. Okay? Notice that elimination is always set up in standard form. Whenever I have two equations in standard form, I do elimination. See? Standard form. X and Y on the same side. X and Y on the same side. X's and Y's are on the same side. Everything is standard form. Whenever both equations are set up in standard form, I do elimination. Whenever I have an equation that kind of looks like it's in slope-intercept, I do substitution. Okay? Because I have a variable that's solved. I know what y is. Okay? So fact of the matter I want to tell you is you do you. If you like doing elimination, then get everything in standard form and do elimination. If you like doing substitution, get it in slope-intercept and do substitution. I don't care your method as long as you can get to that answer. Because if you can get to the answer, who cares what method you used? Okay? And the fact of the matter is, this is on a computer. Am I going to know if you do elimination or substitution? Does the computer know if you are doing elimination or substitution on a piece of scratch paper? No. Computer ain't watching you. Even when you do the exam for this through HonorLock, I'm not going to be looking for, oh man, are they doing elimination on this problem? I don't care as long as you can get to the answer. I don't care what method you use. If you wanted to do graphing throughout all three of these sections, do graphing, although it's not the best. If that's what you like, do graphing. Okay? You do you, boo. All right. So here, there's my little platform that I stand on. In result, in conclusion, do whatever method makes you happy. The other thing is, there are word problems in section 2.3 and 2.4, but I'm not going to talk about the word problems until after I teach you substitution, just like what I did with the linear equations. There were word problems in 1.2 and 1.3, but I didn't talk to you about those until after I taught all the information. Okay? Same thing here. So after I talk substitution, I will do word problems for these. So for right now, skip the word problems. All right. So in order for this to work for elimination, I got to make sure they're in standard form, which means X and Y needs to be on the same side. So the first thing you're going to have to do is we got to take this equation and we got to move X. So we're going to subtract X. And that's going to give us this equation to work with. Negative X plus Y equal to negative 5. Then down below here, in order to fix this, I need to move the Y away from the 10 because I need X and Y on the same side. So I'm going to subtract 2Y. I'm going to subtract 2Y. So that gives us 2X minus 2Y equal to 10. And notice I have the X's lining up and the Y's lining up. Go ahead, pause the video, and now do elimination on this. Although I wouldn't have done elimination, I would have done substitution because it would have been faster. But that's neither here nor there. And go. Okay, so you got to do step 1 because we do not have the goal met. So let's go ahead and get rid of Y this time. So notice I have a 1 and I have negative 2Y. So what did I do before here? All right. So I can't go any smaller than 2. So let's just turn these into 2 because it's easy to turn a 1 into a 2. So I'm going to have a positive 2Y on top and I'm going to keep the negative 2Y on the bottom. So I'm going to make sure my goal is met this way. Okay? So what times 1 will give me 2? And that's 2. I don't have to do anything to the bottom one. So let's multiply through. 2 times negative X is negative 2X. 2 times negative 5 is negative 10. Because we already know what happens when we take the 2 times the Y. Down below, the equation is going to stay the same. So that's 2X minus 2Y equal to 10. And now you're ready for step 2. Hopefully you found out that, oh, everything's canceling out on both sides, which means our answer is infinite solutions. Or in IMathAS, OO, comma, OO. And that's it. That, my friends, wraps up section 2.3. We'll talk about substitution in 2.4 soon enough.